Delta II launches one last time and Japan brings a space elevator to the ISS. Okay, that one is maybe a little clickbaity, but it's real. It's just that, well, it's tiny. It's still important and I tell you why now on kNews. Hey guys, Lucas here. Welcome to kNews for week 37 2018, and as always a big shout out to you my kNews boosters on Patreon. If you like what I do, you can help me out over at funding.knews.space. Thanks for your trust. This week began with a delayed Falcon 9 launch, which I covered in the last episode already, but I'll link you the replay in case you missed it. Japan's H-iib is next on September 13th from Tanegashima. Wait, it got delayed and a new date is not set yet. Sure is, it will head to the ISS, so it will follow the ISS orbit, which is inclined at 51.6 degrees. Up top is Japan's cargo spaceship Kunotori or HTV, which will resupply the ISS with just over 6 metric tons of cool stuff. There are, for example, fresh batteries, scientific hardware, CubeSats and of course yummy food for the astronauts. What stands out to me the most though are two things. One, it will carry a small capsule which will demonstrate a re-entry and parachute landing so that HTV will be able to bring back cargo to Earth similar to SpaceX Dragon in the future. And two, among those CubeSats is one that will test a tiny space elevator called the Space Tethered Autonomous Robotic Satellite, or STARS for short. The experiment involves two CubeSats which will stretch out a string between them, along which a small climber will drive from one side to the other. The most popular of space elevators is of course the one connecting Earth to space, but there are also many other uses in space only. You could, for example, connect two sides of a spinning space station or mount a satellite to an asteroid using a harpoon. The satellite could stay in contact with Earth while a small climber could collect valuable samples from the surface. Tethers are incredibly useful and especially Japan uses them more and more often. They, for example, also deployed a 700-meter long cable to deorbit their rocket's upper stage using Earth's magnetic field. They basically run a very small current from the stage to a small counterweight that generates a magnetic field along the cable. Now, because the counterweight is on another orbit than the stage itself, the tether stays stretched while it experiences a weak force that slows both vehicles down until they re-enter. That's an incredibly interesting solution, I must say, but I'm not 100% sure if they use it on every rocket or if this was so far a one-of-a-kind test on a previous mission. Konnichiwa my Japanese friends, feel free to share more information about that in the comments. But next to launch on my list is India's Pslv on September 16th from the Satish Dhawan Space Center. The Polar Satellite Launch Vehicle will as usual fly south towards a 580 km high sun-synchronous polar orbit. Up top the 4-stage rocket are two primary satellites, one for the United Kingdom's Space Agency and another for the company Surrey Satellite Technology. SSTL-1 here on the left uses a telescope to make pictures of the ground, and on the right is NOVA SARS. SAR stands for Synthetic Aperture Radar, which is itself also short for Radio Detection and Ranging. Acroception right there. I talked about this in a past video already. What such a synthetic aperture does is to simulate a bigger antenna than it actually has by recording the reflected radio wave over a long period of time. This is particularly suited for satellites that orbit Earth really closely and fast. The advantage of a bigger antenna is a higher ground resolution. You can think of it as a bigger telescope lens that can zoom in further only with radio waves instead of light. Small ground features simply have a smaller radio footprint, and the bigger the antenna, the more sensitive it gets. Next to the primary payload, Pslv will also carry some secondary CubeSats, one called Centauri-1 for the Australian-based company Fleet Space. Their goal is to build a small CubeSat fleet to enable cheap, low-bandwidth connectivity for ground sensors distributed all around the globe. This is right for you if you don't need 24/7 connectivity, but instead can wait a day or so for the satellite to fly by your sensor's location again to then upload a couple bytes worth of data to it. The data will then get sent back to a ground station once it passes over it. And the final rocket launch I want to cover this week is of course the last Delta II launch ever on September 15th by the United Launch Alliance from Vandenberg. Target is as usual launching from the US West Coast a polar orbit. Up top is IceSat 2, which is of course an acronym. It stands for Ice, Cloud and Land Elevation Satellite 2 and is going to map and track the global elevation using LiDAR, or light detection and ranging, which is essentially a radar using light instead of radio waves. This is especially important to track the ice coverage on the South Pole. While the North Pole swims and doesn't affect the ocean levels when melting, the South Pole is supported by a giant continent, the Antarctic. As the ice melts, it actually spreads out into the sea and actually looks bigger from up top, so it is incredibly important to also track the overall elevation. A bigger white surface reflects more light to space, so there could be some kind of self-regulating effect where melting ice would lead to cooler temperatures and more ice again. In order to really figure this all out, we need more data and thus more satellites and other experiments. As mentioned in my clickbait title, this was Delta II's final takeoff and I really hope you were able to watch it. If not, I will as always link you the replay in the video description. I have to end this particular episode a little sooner than I wanted to because there are some news on SpaceX front and I will work on a quick video for Monday about that. Stay tuned. If you want to support me and my channel to become a self-sustaining colony on YouTube, please consider contributing to my Patreon campaign. Every dollar helps. Thanks. Okay, that shall conclude this video and I hope to see you in the next one if you like. Auf Wiedersehen and thank you for watching.